Hi, my name is Dr. Farhad Ameri. I am the head of Engineering Informatics Research Group at Texas State University. The mission of our research group is to support knowledge-intensive and cyber-enabled design and manufacturing through application of advanced information modeling, systems engineering, and data analytics. The particular focus of our research is on knowledge representation and modeling and ontology engineering. In this short video, I am providing a brief introduction to our current NSF project titled Measuring Information Content of Artifacts of Early Design. Engineers create different types of engineering documents and artifacts on a daily basis. It is possible to measure the file size for the generated documents, but what if we can measure the amount of engineering knowledge and information contained in each document? For example, what if we can measure how much information is contained in a hand sketch, or in a 3D model of a part, or in a requirement statement? Can we decompose a design artifact into its pieces and measure the information content of each piece? The fundamental research questions that motivate our research include: what is engineering information content? What is a good metric for measuring information content? How it can be measured automatically, and what is the usefulness of information content measurement? If we can measure information content of design artifacts, we can monitor the growth of information and knowledge during product development process. We can also compare the performance of different design teams with respect to information generation rate, and we can assess organizational learning capacity and project-to-project knowledge transfer capabilities. Our technical approach is based on the assumption that information is a form-neutral entity. The same assertion, whether expressed in text, sketch, or graph, contains the same amount of information, and this amount could be measured. Therefore, by translating an artifact into a form-neutral representation and then applying some information metrics, the information content can be measured. We used OWL ontology as the form-neutral representation in this work. The goal is to convert different types of design artifacts into ontological representation. We selected engineering requirements as the example of textual design artifact in this work, and developed an ontology called requirement ontology, or RECON for short, for ontological representation of requirements. RECON can accept both functional requirements and non-functional requirements. Also, logical constraints and axioms are included in the ontology to ensure semantic consistency and validity of the requirement statements. Users can create the requirement instances using a requirement editor. In this way, a requirement statement written in natural language can be translated into a conceptual graph. A graph-based model of requirement statement lends itself to different types of computational services, including information content measurement. We have developed the necessary tools and algorithms for automated measurement of information content based on requirement instances. Our next step is to generalize this methodology such that it can be applied to other types of engineering artifacts, such as functional models, 2D drawings, and QFD diagrams. Thank you for listening.